Welcome to the first class of microeconomics. Now, I will just give you a heads on how we are going to start and what we are going to do in this course. So, to be very frank, we all know that we are left up with 5 to 6 months and we have to finish microeconomics, macroeconomics, maths, stats, some parts of econometrics, and some parts of game theory, DevEco, and other subjects. So the amount of hard work that is required from your end increases because we have to literally go ahead and study for approximately 4 hours every day, whatever happens. Now, when we talk about this course, what we are going to do is we will be doing the major concepts in the live lectures, but each lecture has to be complemented with a majority of examples. For example, if I teach you about a king demand curve concept, if I teach you what is a min plus max function demand curve, you have to go ahead and give 10 examples. You have to go ahead and practice 10 more questions based on it. Only then things will make more sense to you. So what we will be doing is, after I do a live lecture with you, I will be giving you recorded examples based on the utility functions, different kind of questions. And you have to go through those recordings and go through those examples and do them thoroughly before we meet for the next class. Only then things will make more sense to you. Only then. So those examples will be past year questions. So you have to do the recordings of those past year questions that I have done so that you can revise those examples before you sit for the next class and you're very thorough with that concept. Okay. So again, any doubt that you have, you can come and you can ask me on the Telegram. Feel free to post it on the portal. We can also answer on the portal. You can go ahead and WhatsApp. We can also answer on WhatsApp. But Telegram group I usually prefer because when you ask a question, it is not only helpful to you. It helps the 10 other students who are there in the group. And sometimes students answer to students and that enhances your knowledge also. So it's a good way to interact with your group and understand where you stand as comparison with the other students and how much more you have to cope up as against the other students, right? So today I'm going to go ahead and I'm going to begin with the concept which is known as, this is the most, the first lecture of today. So 2/1/2023, and we are going to begin with Marshallian and Hicksian demand function. So before we begin what Marshallian and what Hicksian demand function is, what we want to go ahead and we want to do is we want to understand what is a bundle. A bundle is any amount of the good that I want to consume. So for example, if I say I want to consume 4 units of one good X and 3 units of the good Y, then 4,3, this acts like a bundle. Similarly, if I go ahead and I say I want to generalize it and I want to say I want to consume X units of good X and Y units of good Y, then this becomes a bundle. So a bundle is nothing but the amount of the two goods that I want to consume. Corresponding to any bundle, we have a price vector given to us. So this price vector is actually a price vector of P1, P2. Now, ideally, we can be talking about an n good case also. So I can go ahead and say that, I have n goods. I am consuming X1 unit of good 1, X2 unit of good 2, and so on till Xn unit of good n. We can do this. But, and correspondingly, I can have an n good price also. But mostly when it comes to, going ahead and generalizing things, we will never deal with that. We want to go ahead and we want to only deal with the too good commodity case because that's the most simplest case to begin with. Now, based on this, what we can go ahead and do is write an equation of a budget line. And when we speak of the equation of the budget line, this is how much expenditure I am doing on good X plus how much expenditure I am doing on good Y. So this will give me the total expenditure. And this total expenditure, it must be equal to the total income. So expenditure on good X. If I'm buying X units of good X, each at price P1 into X is the expenditure on good X. If I'm buying Y units of good Y or Y units of good 2, each at price P2, then this is the expenditure on good Y. The expenditure on good X plus good Y, this should be equal to the income of the consumer. This is the simplest way of writing the budget line. Now, if I talk about the slope of this budget line, then what can happen? Now, to find the slope, there are multiple ways. One is you can do perpendicular by base. And secondly, you can find by the method of differentiation. There are two ways. Let's do by the method of perpendicular by base first. So what can I do? I can go ahead and I can plot my budget line. So my budget line is P1 X1 plus, let's write X only, plus P2 Y is equal to M. If I put X equal to 0, what will be the value of Y? It will be M by P2. So I can plot M by P2 units here. This is good Y. If I put Y equal to 0, I will get X is equal to M by P1. This will be here. And this would be my budget. If I just join these 2 points, that will be my budget. The slope of this budget line will be perpendicular by base. So it will be M by P2 divided by M by P1. So this will give me P1 by P2. And since this is downward sloping, it's negatively sloped, I'll put a negative here. So this will become the slope of my budget line, which will be minus P1 by P2. This is one way of finding the slope. We can have another way of finding the slope also. So what can I do? I can say that, okay, this is P1X plus P2Y is equal to income. Let's do a total differentiation of this equation. So how do I do that? I will get P1 dx. P1, P2 are exogenous. They are decided outside the model. Prices and income are given to you. So they will never be differentiated. So P2 dy is equal to dm. Now, along the budget line, the change in income is supposed to be 0. Income does not change. So along the budget line, dm will be 0. So what will I get? I will get P1 dx plus P2 dy is equal to 0. Now the slope of the budget line is perpendicular by base now. Change in perpendicular by change in base is the slope. So change in perpendicular means change in good y by change in good x. That will give me the slope. That means I want to find out what is going to be dy by dx from here. So let's find out that. So P1 dx will be minus P2 dy. So dy by dx will be minus P1 by P2. This is another way to go ahead and find the slope of the budget line. So the aim, first of all, is to understand what is the slope of the budget line, and we have found out that it is minus P1 by P2. Now, let's talk about, acha, here, make a note of this. From intermediate videos, all of you will go through the food stamp program videos from chapter 2 micro. So when you go to the intermediate lecture videos, chapter 2, there you will find something which is known as a food stamp program video. It talks about the kinged budget line concept. You have to go through that concept also. Okay. Now let's talk about preferences. So preferences, basically, they are depicted by utility function. Now, just to give you a base of it, see, preferences were always there in the economy. Whether I ask about which product I want to choose, which car I want to choose, or whether I want to talk about which things should be given preferences in a 5-year plan, preferences always existed. Whether I should be giving more importance to the industries, the big industries, the capital intensive industries, or whether I should be giving more importance to the agricultural sector, that is also a concept of preferences. So when I talk about preferences, they always existed. But what microeconomics does is that it goes ahead and it gives a logical format to those preferences. It goes ahead and it gives a mathematical format to those preferences. So when I talk about the mathematical format of preferences, so please write down, preferences are depicted by utility functions. So when we talk about preferences, we want to go ahead and study the different kind of utility functions. So the first kind of utility function that we have is called u is equal to x into y. A general format of this utility function is u is equal to x to the power alpha, y to the power beta. But if I put alpha as 1 and I put beta as 1, then from this utility function, I will be able to attain this utility function. So this utility function can be a specific form of this utility function, and these are called as Cobb-Douglas utility function. Right? Now, the second kind of utility functions that we have, these are min utility functions, min of xy. So again, the general form of these utility functions is min of alpha x comma beta y. But if I put alpha as 1 and beta as 1, I will be able to jump on to this kind of utility function. These are my complementary goods utility function. And the third that we have is u is equal to x plus y. Again, the general format is u is equal to ax plus by. But if I put this, let's keep this alpha and beta only for simplicity. But if I put alpha as 1 and I put beta as 1, then I will be able to jump from this utility function to this one. And both of them represent substitute. Right? Then the fourth one that we want to deal with is max utility function. So max is represented by max of xy. The utility function that we have is max of alpha x comma beta y. Again, if we put alpha and beta as 1, we will get this utility function. Then we have the fifth one as u is equal to root x plus y. These are quasi-linear utility functions. And finally, the sixth one that we want to deal with is called x square plus y square. And these are concave utility functions. So to be precise, we want to go ahead and we want to understand, these are the maximum utility functions that can come in exam. We want to deal with these 6 kind of utility functions. Nothing more than this can come in exam. So first of all, let's consider the first one. U is equal to x into y. Now for these kind of utility functions, let's go ahead and hold utility constant at some u. So I want to say that my utility, this is held at 4. xy is equal to 4. And let us ask, what are the different combinations of x and y which can go ahead and give me a utility of 4? If x is 1, y can be 4. If x is 4, y can be 1. If x is 2, y can be 2. If x is 1 by 4, y can be, so it can be 16. 16 into 1 by 4 is 4. If x is 16, y can be 1 by 4. All these combinations can go ahead and give me the same level of utility, that is 4. Now, when I plot these different bundles, these are bundles. They are telling me different combinations of the two goods. So when I go ahead and I plot these different bundles together, what will I achieve? I will achieve something which is known as an indifference curve. So an indifference curve will be combination of the two goods, x and y, such that it gives me the same level of utility. It gives me the utility of 4. All combinations of x and y fetching me utility of 4 will become my indifference curve. Now, when I want to go ahead and I want to write this, I want to write some other mathematical notation and I will explain to you what we are doing. So I will write x, y greater than equal to 0. Just to show that my x and y's can only lie in the first quadrant. I can't go below that. I have to have positive consumption of the two goods. Or I can go ahead and write that x belongs to R. Don't get too much worried by these notations. So x belongs to Rn plus. It has to be a real number. It has to be a natural real number. It has to be a positive real number. So this just says that, R plus just says that my consumption set in this case is a positive set. Whether it is natural or integer does not worry. It has to be a real number. This is all it says. But it has to be a positive real number, which means it can only be in the first quadrant. And this n on top of it, it represents the n is the number of good scenario. Okay. So just I want to highlight this thing. So when we say the spaces are in any question, it means that it can belong anywhere from -infinity to infinity. When I say that the spaces are plus, it means 0 is included, but it can go till infinity. So 0 unit consumption is possible, but I can consume anything till infinity. When I say R plus plus, it means that anything between 0 to infinity, but 0 not included. So dekho, when I talk about consumption of goods, I can consume 0 unit also. Especially when I talk about substitute goods, I will consume one in positive amount and other good I will never consume. I will consume only the good which is cheaper. So when I talk about consumption of goods, they can include 0 units also. So this will be the right thing to say. So we can say that consumption of goods will be in the R plus space, which means it can either be 0 or positive. But can prices be 0? No. Prices always are positive. Prices cannot even be 0. You can't give things for free. So when it comes to prices, it will be in the R plus plus space, not even in the R plus space. So we can say that prices will usually belong to R plus plus space. So right now, we can write here that if price is 0, good is available free of cost, in such case, there will be infinite demand of the good. So for example, take the case of air. Air is available freely. We are not really paying anything for the air, for the oxygen. Because we are not paying anything for it, everyone is demanding it, right? And they're demanding infinitely. Everyone is consuming 24/7. So when the price of the good becomes 0, in that case, I will show you an example. Economic interpretation sometimes is possible and sometimes it becomes very difficult. So usually we will always assume that P is in the R plus plus space, and we will assume that demand is in the R plus space. Okay. So now I'm back to the concept of indifference curve. I want to go ahead and I want to plot this. So how do I go ahead and plot this? So this is good Y, good X. I can have 1 unit of X, 4 units of Y, 1 unit of Y, 4 units of X, 2 units of Y, 2 units of X, and other points. When I join this, I get my indifference curve. This is a typical 2 commodity case that we are doing. Now let's talk about the equilibrium condition. For this typical Cobb-Douglas function, note that this case, this Cobb-Douglas utility function, in this case, we cannot have X equal to 0, neither can we have Y equal to 0. This is the case where both the goods are equally important. Just consuming one good will never fetch me any level of utility. So for example, if I tell you that in this case, I am going to give you 1 lakh units of good Y, but I'm going to give you 0 unit of good X. My utility remains 0. Similarly, if I give you infinite units of good X, but 0 units of good Y, then also my utility will be 0. So this is a case where X and Y are kind of complementing each other. You cannot get any level of utility. Even if you give a very, very small amount of X, I am fine. So you give me 0.0000001 X and you give me a lot of Y, I will get positive utility. But you can't give me 0 unit of X. My utility will become 0, right? So which means that these utility functions, these ICs, they will tend to become closer and closer to the X and Y axis, but they will never touch X or Y axis, because that will mean zero utility. And this IC represents positive utility. It represents positive utility. So we want to go close and close to the x-axis or y-axis, but not intersect the x or y-axis. Okay, let's talk about the equilibrium condition for such cases. So the equilibrium is achieved by the tangency condition. I will first teach you this tangency condition, and then I will teach you something which is universal and you should know it, which is called the Lagrange method. So let's talk about tangency condition first. So I have this as my budget line, and for this given budget, I want to attain as high IC as possible. So I start with an indifference curve and I want to go as high as possible. The highest indifference curve that you attain is at the point of tangency. So at the point of tangency, what do you see? You see that the slope of IC becomes equal to the slope of budget. The slope of IC is called MRS. The slope of budget line is just what we found out, PX by PY. Now let's talk about the utility function that we derived. So my utility function was X into Y. This was my utility function. MRS is the slope of indifference curve, and this is defined as MUX by MUY. MUX is how your utility changes as X changes. MUY is how your utility changes as Y changes. So when I differentiate my utility function with respect to X, I hold Y constant. So Y is just a constant. Constant means, so for example, if I tell you differentiate 4x with respect to X, what will you get? 4, because 4 is a constant. Similarly, differentiate xy with respect to X, you will get Y, because Y is a constant. Differentiation of X will be 1. So when I differentiate xy with respect to X, I hold Y as constant, and I get the answer as Y. Similarly, when you differentiate with respect to Y, you will get the answer as X. So when we talk about MRS, MRS is given by Y by X. Now at equilibrium, you will go ahead and equate MRS to PX by PY. So what will we do? Y by X is equal to PX by PY. This implies PY into Y is equal to PX into X. This is another important equation. Very, very important equation. What does this say? See, if you notice, PY into Y is the expenditure on good Y. I am consuming Y units, each at price PY. So PY into Y is expenditure on good Y. And PX, X is expenditure on good X. Okay. So, Khushbu, MRS is marginal rate of substitution. Marginal rate of substitution is the slope of IC. So when I have my indifference curve here, the slope of the indifference curve, that means if I find out perpendicular by base of the indifference curve, how, what is the change in good Y upon change in good X? That is MRS. So MRS basically tells me what is the rate at which you will be substituting one good for another. So for example, if I tell you that my MRS is 1 unit of good Y for 4 units of good X, that means that if you want 1 unit of good Y from me, right, then you will have to give me 4 units of good X in exchange. So the rate at which I will substitute one good for another, how many goods am I willing to give of one good in exchange of the other good, that is called MRS. Okay. And how do we represent MRS? MRS is represented by MUX by MUY. MUs are marginal utilities. So MUX is marginal utility of X. That means what is the additional utility you get when you consume an additional unit of good X. Take an easiest example. Just say you go to the shop of a pani puri owner, a golgappa owner, and you start eating pani puris. After you keep eating these pani puris, when you eat one pani puri, what is the utility that you get? Maybe you get a utility of 10. Then you consume one more pani puri. Maybe that additional pani puri gives you utility of 8. So what is the additional utility you get every time you consume an additional unit? That is called marginal utility. And how do we find it? By differentiating the utility function with respect to that good. The ratio of the marginal utilities is MRS, right? So MRS is MUX by MUY. MUX is differentiate the function with respect to X. MUY is differentiate the function with respect to Y. In English terms, this tells me the change in utility when you change the demand of X, change consumption of X, or change consumption of Y. That's MRS. For this, you can also refer to the intermediate lectures. Lecture chapter number 3 and 4. That is only telling you in very, very detail exactly what MRS is. Okay. Okay. So when I equated MRS to the ratio of the prices, I got this equation. PY into Y is equal to PX into X. PY into Y matlab kya? How many is my expenditure on good Y? Just for example, if I buy 10 units of good Y, each at price 4, then 40 is the expenditure on good Y. Okay. And PX into X is what? What is my expenditure on good X? So for example, if I buy 20 units of good X, each at price 2, that is my expenditure on good X. My equilibrium situation says that the expenditure on good Y is equal to the expenditure on good X. Only for Cobb-Douglas goods. Only for these goods. This is going to happen. So let's write this down. For utility function UXY is equal to X into Y, equilibrium. What was equilibrium? When I equated MRS to PX by PY, it gave me Y by X is equal to PX by PY. This means it gave me Y into PY is equal to X into PX. This means it gave me that the expenditure on good Y must be equal to expenditure on good X. Now think about this. If my income is 50 and I have given you in the question that the utility function is X into Y, and I'm asking you, what is your share of expenditure on good X? Suppose, can you, any one of you, tell me what will that be? I have given you that your utility function is XY and your income is 50. What will be the share of expenditure on good X? Good. So I know that I will be spending equally on good X and good Y because it is a Cobb-Douglas utility function. That means that I will be spending 25 rupees on good X and I will be spending 25 rupees on good Y because of this property. And if I will be spending equally on good X and good Y, then the share of my expenditure will be 25. I'm spending 25 rupees out of an income of 50 into 100. That means I'm spending 50% of my income on good X. And I'm spending remaining 50% of income on good Y. From the property that we just defined, that XPX should be equal to YPY, we get this situation. So this is an important point that we derived. Now let's go back to the budget line. So budget line says XPX plus YPY is equal to income of the consumer. But from our equilibrium condition, we have got that and XPX is equal to YPY. So can I replace this YPY with XPX only? We have got this condition. So I will get XPX plus XPX is equal to M, or 2XPX is equal to M, or X is equal to M by 2P. Put this value back. So XPX is equal to YPY. This implies Y will be X into PX by PY. If instead of X, you will write this value, you will get the answer as M by 2PX into PX by PY. So your answer is going to be M by 2PY. So what you will get? You will get X star as X as M by 2PX and Y star as M by 2PY. This will be your final equilibrium. This is something that all of you have to remember. This is not that we will be deriving in every class. Later on, when we will see the objective kind of questions, this will be used by us. So just see to it. What we are doing, we are given a utility function xy. We are given a budget line px into x plus py into y is equal to m. Step one that we are going ahead and we are doing is we are finding MRS from this utility function. The MRS of this utility function is MUX by MUY. When you differentiated it with respect to X, you got the answer as Y. When you differentiated it with respect to Y, you got the answer as X. The slope of the budget line is PX by PY. We equated MRS to PX by PY. That means we equated Y by X to PX by PY. By equating Y by X to PX by PY, we got this. XPX is equal to YPY. Then we went to our budget line equation. This is my budget line. XPX plus YPY is equal to M. We know that XPX is equal to YPY. So instead of YPY, we just plugged in XPX. The entire equation became in terms of X. We solved for the value of X. When we did that, we got the answer as M by 2PX. Again, we used the same relationship that we had here. Instead of X, we plugged in M by 2PX. So we got M by 2PX into PX is equal to YPY. We cancelled this out and we got Y is equal to M by 2PY. So this is the final values that we have. X is M by 2PX and Y is M by 2PY. This is a general solution. This is very basic. This we have to develop on this. This basic will not come in exam. So this is a general solution of the utility function xy. So for example, if they tell you that income is 100, price of good X is 4, price of good Y is 5, and they tell you find equilibrium X star Y star, then what will you do? Use this formula. Because I know that they have given the utility function as xy. So then my X will be M by 2PX, 100 by 2 into 4. That means 25 by 2. And my Y will be M by 2PY, 100 by 2 into 5. So I just used this formula that I defined. I just plugged in M, PX, PY in this and I got the answer as 12.5. What does this mean? This means that if I take a budget line and I take a utility function, then this point of my equilibrium, this tangency condition, this is where I consume 12.5 units of good X and 10 units of good Y. So this equilibrium that I have got, this is this. This is what this is telling me. this is method 1 to do things. Method 1 is where you equate MRS to PX by PY. Now let's talk about method 2. Method 2 is called Lagrange method. You must practice all of this at least twice today. Only then things will sink in your mind. Here, you are given the same utility function. You are given the same budget line. The aim is to find X star and Y star. How do we do it? I form something which is called a Lagrange, represented by L. In this Lagrange, we will first write this objective function. So I've written this. Then I will put a plus sign. Then I will write something which is known as a Lagrange multiplier. This is called Lagrange multiplier. Then I will start bracket. In bracket, I am going to write this constraint of mine. And how do I write this constraint? I will write this constraint by writing this value first. So I will say M and bring this part on the other side. That means M minus Px into Px into X minus Py into Y. This format of writing things, this is called a Lagrange. In economic honors, this is taught in the first semester. So this is the basic Lagrange method that I'm doing. Once you form this Lagrange, you are supposed to differentiate this with respect to X, Y, and this lambda. So differentiate this with respect to X. What will I get? Whenever you will differentiate with respect to X, you will hold Y constant. So here in XY, Y is a constant. So you will get the answer as X. Oh, sorry, Y. Y is a constant now, and differentiation of X is 1 plus lambda. Here there is no X, so its differentiation is 0. Here differentiation of X will become 1. Here there is no X, so its differentiation is 0. And you will equate this to 0. So you will get Y is equal to lambda into Px. Just try this and differentiate with respect to Y yourself. So differentiate Lagrange with respect to Y. X is a constant. So differentiation of xy will be X. Differentiation of Y is 1 plus lambda. Differentiation of M, there is no Y in it, is 0. There is no Y in this, 0 minus Py into 1 is equal to 0. From here you will get X is equal to lambda Py. This is equation 1. Equation 2. Okay. Always you will follow the same technique in Lagrange. Then step number 3, you will differentiate this with respect to lambda. When you differentiate this with respect to lambda, differentiation of lambda will be 1 and everything coming with it will come as it is. जैसे xy का differentiation में, when you did it with respect to x, so x became 1 and y came as it is. So what comes with lambda will become as it is. So you will have m minus px into x minus py into y equal to 0. So from here I will simply get m is equal to px into x plus py into y. I will call this as equation 3. Step 4. You will divide equation 1 by equation 2. Always. So what will I get? Equation 1 was y is equal to lambda px. Equation 2 was x is equal to lambda py. And you're going to divide this. Lambda and lambda will get cancelled. Just 1 equal to left. So you will have y py is equal to x px. This should ring a bell. This is exactly the equation we had got when we followed method 1. When we equated MRS to px by py. When we equated slope of IC, slope of budget line, that means MRS to px by py, we got exactly this equation. And this interpretation also we did, that expenditure on good Y must be equal to expenditure on good X. We've also done this. So this is a familiar equation. I have got this as equation number 4 by dividing these two equations. Now put 4 in 3. This was my equation number 3. M is equal to px into x plus py into y. I just got that px into x should be equal to py into y. This is what this tells me. So my third equation was m is equal to px into x plus py into y. So m is equal to px into x plus px into x, because both are equal to each other. So 2px into x is m. So x is m by 2px. And then you can solve for y. You will get this. So you are getting the same answer, whether you follow your method 1 or method 2. But learning Lagrange is important. Sometimes we want to revert the scenario, right? Sometimes my utility function may be something different. So it's a good idea to at least know what this Lagrange is. So let's write down what we did in this class first of all. The aim was to find equilibrium consumption of good X and good Y given the income and prices. The aim is to find what is X star and Y star. And how did we did it? For Cobb-Douglas, utility function, you will find tangency condition. How will you do that? By equating MRS to px by py, and then you get your X star as m by 2px and Y star as m by 2py. This is what my equilibrium is. Now, I am going to go ahead and give an official name to this. So if you notice, the equilibrium that you are getting, it is a function of the income of the consumer and the prices of the goods, isn't it? The equilibrium is the function, because this can be determined if I know income and prices. Income and prices. So the equilibrium is a function of income of the goods of the individual and prices of the goods. Such an equilibrium is called Marshallian equilibrium. Please write that down. The equilibrium of goods as a function of income and prices of the goods is called Marshallian demand function. So every time you see, जैसे अगर suppose in exam you are given this, here X depends on income and prices of the good. This is Marshallian. But suppose in exam you're given this. Here X depends on prices, but it depends on utility. It does not depend on income. It depends on utility of the consumer. कितना utility चाहिए उस पे depend करेगा X की consumption. This is not Marshallian. Marshallian has a definition that it should only be a function of income and prices. It should not be a function of any other thing. If you see utility in it, then it is not Marshallian demand. Now just think about this. I got U as XY. शुरू में मुझे एक क्वेश्चन में ये गिवन था, U was X into Y. Then I started solving, and when I equated MRS to PX by PY, I got X star as M by 2PX. Yeah. And I got Y star as M by 2PY by equating this, or by Lagrange method, जिससे भी करना है. X star will come as M by 2PX. Y star will come as M by 2PY. Just tell me something. Can I say that the maximum utility that I can get, utility maximum कब होगा? जब मैं ये optimal bundle consume करूंगी. So the maximum utility I can gain is when I consume these optimal bundles. What will be the level of that utility? Just put X की जगह पे M by 2PX and Y की जगह पे M by 2PY. So this will give me M square by 4 PX PY. This utility. यहाँ पे utility was a function of X and Y. Here utility has become a function of income and prices. This is called indirect utility function. Please write this down. The utility function, which is a function of X and Y, ये जो शुरू करता, this one is called direct utility function. Please continue. The utility function, which is a function of income and prices, is called indirect utility function. Okay. So what we have learned, what is Marshallian demand? What is a direct utility function? What is an indirect utility function? Now, एक बात बता, whatever is the income of the consumer, will he do an expenditure equal to income only? अब अगर मेरी income 100 है, if I have an income of 100, how much money can I spend in the market? 100. I can't spend more than that, no? So expenditure maximum can be equal to the income of the consumer. If the consumer is on the budget line, that means he is spending his entire income, spending all income. If he is below the budget line, he is spending less than income. Where did we get our equilibrium? Our equilibrium was where we had this tangency condition, this point. That means our equilibrium was on the budget line. That means we were spending our entire income. So expenditure was equal to income. जितना खर्चा कर रहे थे वो उतना ही था जितना income थी consumer की. Because you were on the budget line. Your equilibrium is on the budget line. Your expenditure and income are equal to each other. Now, if that is true, can I say that here I can replace my M by E because expenditure and income are the same? So I can write that U is equal to E square by 4px py. I have replaced this M by E because income and expenditure are the same thing. So we can say since income and expenditure are equal, M is equal to E. From here, find the value of E. So E square is 4px py into U. So E will be under root of 4px py into U. That means it will be 2 under root px pyu. This is called the expenditure function. You have to see where we started and where we have reached. We started with direct utility function. सिर्फ x u is equal to xy given था. From direct utility function, we derived Marshallian demand. We put that Marshallian demand back and we got indirect utility function. Then we replaced M with E. And what we got was called the expenditure function. So we can write that the expenditure function is a function of prices and utility. One last step is left in this. Then that entire analysis is over. Once you get this expenditure function, we can differentiate expenditure function with respect to px and with respect to py. यहाँ differentiate करके जो मिलेगा, that is called Hicksian demand of good X and Hicksian demand of good Y. So let's differentiate this with respect to px once. बाकी सब constant है. So I will write this as 2 root py root u root px. इसको just open किया है. This is constant. This is constant. And differentiation of root px will be 1 by 2 root px. So I will get 2 root py root u and uska differentiation ho jayega 1 by 2 root px. All of you should know differentiation of root x is 1 by 2 root x. So if I just cancel this, I will get py into u by px under root. This is called Hicksian demand of good x. Similarly, when you will differentiate with respect to y, you will get px u by py under root. This is called Hicksian demand of good y. Please write it down. The Hicksian demand of good x and good y is a function of prices and utility of the consumer. This method, जिसमें हम इसको expenditure से differentiate करते हैं, this method in economics, this is called Shepard's lemma. Actually, Marshallian or Hicksian है क्या? What did we do? Why are we doing this? What's the aim behind it? So, actually, both are same thing. There is no difference between the two. Marshallian actually states that, look, I am giving you a some level of income. I have given you some level of income. What is the highest utility you can attain? So he wants to go to the highest IC. What is Hicksian doing? Hicksian is saying, I have given you one level of utility, U bar. I have given you this utility. What is the minimum expenditure? What is the minimum money in which you can attain it? So can you attain it in this level of budget? No, no. I can go to a lower budget. I can go to a lower budget. So this is the minimum income in which I can go and achieve the same level of utility. Both of them reach the same conclusion. Both of them will reach the same tangency condition. Tangency condition here and tangency condition here. But in Marshallian, we are given one income level and we want to reach highest possible utility, highest possible IC. That is why it is a function of income and prices. And here we are given one level of utility and we want to achieve it in the minimum money possible, in the minimum expenditure possible. That is why we differentiate the expenditure functions. We minimize them and we ask what is X and Y. And that is why it is a function of utilities. Because we are saying that I want to attain this utility. Utility itna hi chahiye. What is the minimum income, minimum expenditure in which I can attain it? So both come to the same answer, but both approaches are different. This is very, very important from exam point of view. This is only one. We have only done it for Cobb-Douglas. We have to do the same process for complementary good, substitute good, quasi-linear, max function, concave preferences. For all of them, same process. We begin with direct utility function. We go till Shepard's lemma and indirect. So make a table out of it for today. And then we will do the same process for other cases in the next class. Please write it down. We started with direct utility function today. We equated MRS to PX by PY. This is Cobb-Douglas goods. We got X star as a function of income and prices, Y star as a function of income and prices. This was called indirect utility. No, but this was called Marsharian demand. We put back these X stars and Y stars in this utility function, in the direct utility function. And then we got utility in terms of income and prices. This was called indirect utility function. From here, we found value of E, that is expenditure, by equating M equal to E. This was called expenditure function. Finally, we differentiated expenditure with respect to PX, differentiated expenditure with respect to PY, and what we got was the Hicksian demands. So finally, we got Hicksian demand. Hicksian was a function of utility and prices. This is the entire steps that you have to follow for any question that asks you different aspects. Just say in exam, they will ask you find the expenditure function. So I will stop here. If they ask me find indirect utility function, I will stop here. So it depends on what the question is asking me. Is this clear? It may seem a bit on the top, but 10-15 days into the subject, this will seem the easiest thing. You have to give some time to it and practice it on the same day. A lot of these concepts are explained in the intermediate videos. I mean, it will be difficult for me if I deep dive into what is marginal utility now, right? Or what is budget line. So that can only be done through those intermediate videos. I will deep dive into what is going to come in exam. Setting a little base is where you have to go through the intermediate videos and you have to ask me doubts from those. So gear up, start studying micro from today onwards. If you want to go ahead and do some part of intermediate, you can do chapter 2, 3, and 4. I will be using these plus live lecture, what we did today. That should be enough before we meet for the next class. Okay.